Okay, so this is a video instruction for the Milky Way lab, but I will add a little bit more to this. Basically, you're going to study a little bit of a feature of the Milky Way galaxy. Part A is simply giving you a study about the structure or the distribution of the Milky Way. And what you would do is you will look at 7 different regions. You can randomly pick 5 different regions following the instruction. Milky Way 1, 2, 3, and 5. And of course, the North Galactic Pole and the South Galactic Pole, meaning you're looking towards 2 particular directions here, but then 5 random regions, okay? And then you will literally count literally a region and how many stars is in that region. And I remind you that if you read over the instruction, of course, in order to make comparison, correctly, comparing apple to apple, you want to make sure the field of view is 1 degree for each region. Of course, you don't have to have 1 degree for as long as you're consistent. Let's say you do 0.5 or 2 degrees. Just make sure that you are doing the same for each region, okay? But of course, you don't want it too large, because if your field of view, if your region is too big, you'll be counting a lot of stars. That's a lot of time, a lot of effort, okay? So do a little bit smaller, not bigger. It's okay to do 0.75 degrees. It's all right. What you will see is you're not supposed to see the same star count. You definitely should see a very distinctively different or different sets of counts, and telling you that the distribution for the Milky Way galaxy is not uniform, right? This is really something that you definitely need to catch, okay? So make sure you follow the direction correctly. Make sure that the field of view is consistent for each of the 7 regions, and make sure you understand they are telling you something here. You're not supposed to see them all the same, right here, okay? And they ask you some same question, but it should be obvious once you get the counts right. But part B is what's important here, and let me explain that these are basically globular clusters, okay? All right, globular clusters. And so it's kind of amazing that many of the globular clusters were already identified by the French astronomer Messier, right? Because this is designated object 2, 3, 4, and so on, all the way up to 100 and so on, okay? So Charles Messier has already identified many of these globular clusters when he was building these catalogs, and a high number of these objects were globular clusters. Okay, so he already did this job for you. And so we are still using the Messier designation, M2, M3, M4, and so on, all the way to M107. But of course, there are a few more that were not identified because they're a little bit harder to see and they're farther away at the time. And so these are the NGC designation. Basically, all these were globular clusters designation. So what you're doing is you're repeating the observation of Harlow-Shapley. Remember Harlow-Shapley used globular cluster to map out the distribution of the Milky Way in terms of, for example, location and distance scale. And you're going to do the same thing here, but you're going to do it in an easier way. Remember, Harlow-Shapley needed to understand the distance, but here we use a clever way, and that is just to identify the constellation. Once you understand how this is done, then maybe Harlow-Shapley could have done the same way, right? But the clever way, at least for this class, is to just identify the location in terms of constellation. So let me just give an example. At the end, for this lab, you need to turn in this plot, okay? So print out the sheet. Literally, you have to print it out and make a mark, okay? Let's say you found an object in 25, and that is in the constellation Auriga. And just make a big mark right here. Use whatever color you have. You don't even have to know where it is. because it's in this constellation, just make a mark in the center. It's all right. You don't have to be exact. Because the idea is, if these globular clusters are randomly distributed, they would be in random location within each constellation. And marking them at the center is good enough to see the overall distribution, where they are located, okay, and what is the shape of the Milky Way galaxy. Okay, does that make sense to you? Okay, if you don't, you better ask now, because this is the instruction. Basically, any globular cluster, use Stellarium, find out which constellation that it belongs to, and just mark a big X right here. Use any mark you want, any color, red, make a cross or a circle in the center. Or let's say you found one in Carina here, just make it in the center. It doesn't matter where, mark it right here. All right, and that's it. Now, the definition of constellation, and I'll say this again, and because I still see some students mistaking the word constellation with what we call asterism. In the old ways, we consider a constellation like this group of stars, right? So let me pick Centaurus. Let's see. That's why I was looking at Centauri. Okay, Centaurus. Oh, missed it. Oh. Okay, right here. See, this is Centaurus right here. You see, Centaurus is this region right here. This is what we mean by the constellation Centaurus. It's a region, okay? So, for example, let's say you go to Wikipedia and you look at, you can type in anything you want. You can type in Virgo, Ursa Minor, whatever, and they will show you literally the region that it is. Okay, so let's go into what it looks like. So this is the region we call the Centaurus constellation. Okay, so it looks like this, isn't it? Okay, so that center right here. And of course, this is the famous Alpha Centauri. Okay, right here. Right here. All right, so a constellation, so some students still get confused and say, oh, it looks like it's halfway between certain constellation. When I see that statement, I know right away you didn't understand the definition of constellation. Because these boundaries are well defined, any star, any object belongs to only one constellation. Let's say right here, then that belongs to Centaurus. Okay, and so when Stellarium tells you a certain star belongs to Centaurus, it means that it is within this boundary. Does that make sense to you? It doesn't mean it's closer to the Centaurus asterism than Musca or Crux. Okay, for example, let's say you have a star right here. If you just look at these stars, the Centaurus stars and the Crux star, you might think this star right here is closest to Crux, but it's actually located within the boundary of the Centaurus. So make sure you understand, a constellation is a boundary, okay? And I say this again and again, that is the modern IAU definition of constellation, okay? So when you go through this table and use Stellarium, it tells you what constellation it is. Basically, it's telling you which region that you're supposed to draw this in, okay? Any question? Any question? No? All right, so when you complete this table right here, it's actually very quick, okay? When you complete this plot right here, complete the table and make a plot, make sure you submit the plot. This is what I need to see. Okay, all this table, that's obvious, but you need to literally make an effort and draw, make a mark for each globular cluster, what constellation it belongs to. Okay, so that's the instruction.